Welcome to The Explainer. Today, we're taking a fascinating journey literally straight down beneath our feet. We're going to explore how dirt, rocks, and raw energy form the invisible yet absolute bedrock of our modern civilization. Everything around you right now, the device you're using, the building you're sitting in, even the food you eat, it is all inexorably tied to the Earth's crust. Okay, let's dive into this. Have you ever actually stopped to think about what your daily morning routine has in common with a deep underground mine? I know, it sounds like a totally crazy comparison. You wake up, stroll into a brightly lit bathroom, brush your teeth. It feels completely disconnected from, heavy machinery and dark subterranean tunnels. But the reality of your physical world is way more interconnected than you might think. A simple tube of toothpaste? It's actually a marvel of global mining. Those abrasives that clean your teeth, that's silica, limestone, and aluminum oxide. The fluoride fighting off your cavities comes from a mineral called fluorite. And if your toothpaste is that pristine, bright white, well, that color comes from titanium oxide, which we pull from minerals like rutile and ilmenite. Got a little sparkle in there? That's mica. Even the tube itself is made of plastics derived from petroleum. So just brushing your teeth literally connects you to extraction operations all over the planet. And it absolutely doesn't stop at the bathroom sink. Check this out. Minerals make up only about 0.3% of our total nutrient intake. It's a tiny, tiny fraction, right? But here is the wild part. Without that microscopic 0.3%, our bodies just wouldn't be able to process or utilize the other 99.7% of the food we consume. Minerals are basically the literal spark plugs of biological life and modern human living for that matter. So here's our roadmap for today. We're going to explore minerals in your daily life, where they hide in the earth, the heavy lifters of industry, the dark side of mining, and finally, powering the future. Let's jump in. Section 1. Minerals in your daily life from toothpaste to tomorrow. Think of a village boy seeing a massive city bus for the very first time, and suddenly realizing it's made of mined iron rather than brick. It's a pretty powerful reminder that our built environment doesn't just magically appear, it has to be extracted. Now, to ground all these fun facts, we really need to look at how geologists formally define a mineral. Simply put, it is a homogeneous, naturally occurring substance with a definable internal structure. Nature gives us an incredible spectrum here, going all the way from the hardest diamond down to the softest talc. When elements combined under very specific physical and chemical conditions, they create these distinct structures. And what about rocks, you ask? Well, rocks are essentially just combinations of these minerals. Take limestone, for instance. It's actually just a single mineral rock. Moving on to Section 2. Where do minerals hide? Unlocking the Earth's vaults. You see, geologists don't just dig randomly. They hunt for what we call ores. These are commercially viable accumulations of minerals mixed in with other elements. Now, what's really interesting about this is how the Earth actually hides its treasure. It essentially does this in 5 distinct ways. In igneous and metamorphic rocks, molten or gaseous minerals are literally forced upward into cracks, cooling and solidifying into veins and lodes of things like copper and zinc. Alternatively, beds or layers form horizontally over time, which is exactly where we get coal and iron ore. Then there's residual mass. This is what's left over when surface rocks decompose, giving us materials like bauxite. Placer deposits are super fascinating. These are heavy, non-corrosive metals, think gold, silver, platinum, that wash down and settle into valley sands. And finally, the massive ocean waters and beds hold vast quantities of dissolved salts, magnesium, and those cool little manganese nodules. Section 3. Iron, copper, and beyond. The heavy lifters of industry. To really grasp how these minerals shape our civilization, we're going to use India's incredibly diverse geological landscape as our main case study. When we talk about metallic minerals, we generally divide them into ferrous, meaning they contain iron, and non-ferrous. Now, India is incredibly wealthy in ferrous minerals. They've got magnetite, which is the absolute finest iron ore out there, boasting up to 70% iron content, and these excellent magnetic qualities that are just essential for the electrical industry. Then there's hematite, the most industrially important iron ore. India actually has massive, super high-grade hematite belts in regions like Odisha and Chhattisgarh. But contrast that with copper. Copper is non-ferrous, incredibly malleable, ductile, and a fantastic conductor. It is absolutely vital for modern electronics and cables. However, India is critically deficient in copper reserves. This shortage forces a heavy reliance on specific mines in Madhya Pradesh and Rajasthan, and it requires a lot of imports to make up the difference. When it comes to bauxite, the regional concentration is staggering. Remember bauxite? That's the residual mass we talked about earlier, formed from the decomposition of rocks. We use it to produce aluminum, which is highly prized because it combines the strength of iron with extreme lightness and really good conductivity. Well, a single Indian state, Odisha, produces an overwhelming 65% of the country's bauxite, all thanks to the massive deposits in the Koraput district. It just goes to show, geography really is destiny when it comes to industrial development. So the crucial point here is that it's not just the shiny, glamorous metals doing all the heavy lifting. Non-metallic rock minerals are totally the unsung heroes of our infrastructure. Take mica, for example. It splits into leaves so incredibly thin that you can literally fit 1,000 of them into just a few centimeters. And because it has excellent dielectric strength and a high resistance to high voltage, it is completely indispensable for our electrical grids and electronics. And what about limestone? It's the basic raw material for the cement industry, and you absolutely need it to smelt iron ore in blast furnaces. No limestone, no modern cities. It's that simple. Section 4. The dark side of mining, the human and environmental toll. Because while these materials are absolutely essential, extracting them comes with some severe hazards that we simply cannot ignore. The source text highlights a very specific and pretty sobering example. Quote, in Meghalaya, coal mining is done by family members in the form of a long, narrow tunnel, known as rat hole mining, end quote. Our sources point out that even though the National Green Tribunal has declared this practice illegal, it still persists in certain tribal areas. It really underscores the stark human reality and the desperate economic drivers that sit right behind resource extraction. The hazards we're talking about are completely systemic. Miners face a frighteningly high risk of pulmonary diseases from constantly inhaling toxic dust and fumes. There's the ever-present danger of collapsing mine roofs, sudden inundation or flooding, and devastating mine fires that can literally burn underground for years, especially in coal fields. And on top of that human toll, the environmental degradation is massive. Water sources get choked and contaminated by slurry, and vast tracts of land and soil are permanently degraded. The only viable path forward here relies on vastly stricter safety regulations and the uncompromising enforcement of environmental laws. And we have to manage these risks incredibly carefully because of one stark reality. Workable, commercially viable minerals make up only a tiny 1% of the Earth's crust. 1%. They are rapidly depleting non-renewable resources. Our current rate of consumption is vastly outpacing the millions of years it takes for geological replenishment to even happen. As mines have to go deeper and deeper, extraction costs shoot up, and the quality of the ore inevitably drops. Which brings us to Section 5, powering the future, the energy transition. Because all this extraction and civilization building, it requires an unfathomable amount of energy. Let's zoom out and look at the timeline of our energy consumption. Now, coal is the most abundant fossil fuel, right? It's formed from compressed plant material. But the highest quality coal fields, like the Gondwana deposits in India's Damodar Valley, took over 200 million years to form. The tertiary coal fields took about 55 million years. Yet in just the modern era, which is essentially a microscopic blip in geological time, we are rapidly extracting and burning right through these massive fossil fuel reserves. And this brilliantly illustrates the critical crossroads we are currently at. Conventional energy sources like coal, petroleum, and natural gas are obviously highly effective, but they carry massive environmental costs and are strictly finite. Furthermore, over 70% of rural energy needs in places like India are still met by burning firewood and dung cake, which is completely unsustainable and leads to heavy forest loss. Now contrast that with non-conventional renewable sources. We're talking solar energy utilizing photovoltaic technology, vast wind farm clusters like those down in Tamil Nadu, biogas plants processing agricultural waste, and even geothermal energy. Shifting to these renewable sources isn't just a nice environmental preference anymore. It's an absolute necessity to counter rising fossil fuel prices and a very finite supply. But here's the thing. The transition isn't just about finding new ways to generate power. Economic development absolutely requires energy, sure, but efficiency is just as critical. Our sources highlight a truly powerful motto: energy saved is energy produced. Conservation is the most immediate tool we have in our arsenal. That means individual actions actually matter, choosing public transport, switching off those unused electrical devices, and investing in power-saving technology. Which brings us to our final question for today. We started out by looking at how the Earth shapes your morning routine, but the reverse is also entirely true. How does your personal energy consumption shape the geological future of the planet? Every watt saved, every material recycled, eases the pressure on that precious 1% of the Earth's crust. So think about the hidden minerals and energy the next time you turn on a light or pick up your phone. Thanks so much for joining me on this explainer, and keep exploring the incredible world beneath our feet.